Hello everyone. Now let's look at hypothesis testing question. Here is the question. This insurance company claims department reports that the mean cost to process a claim is $60. An industry comparison showed that this amount to be larger than most other insurance companies. So the company instituted cost-cutting measures. To evaluate the effect of the cost-cutting measures, the supervisor of the claims department selected a random sample of 15 claims processed, and the cost of claims are shown here in column 1. So at the 0.01 significance level, is it reasonable to conclude that the mean cost to process a claim is now less than $60? So this is a hypothesis testing question. As we have learned in class, for any hypothesis testing question, we can follow the 5 steps. The first step is to state the null and alternate hypothesis. So in this question, what is the H0 and H1? We need to first find what is the claim to be tested in this question. So the claim to be tested is here. Is it reasonable to conclude that the mean cost to process a claim is now less than $60? So this is our claim. Mean cost to process a claim is less than $60. The claim, usually we put it as H1. So what we can write here is mu smaller than 60. Therefore, the null hypothesis will be the other side, bigger than or equal to 60. Some errors I have seen in the past few years are like this. For example, some of you write in this way, H null bigger than or equal to 60. Or some of you write H1 in this way, mu smaller than or equal to 60. Or some of you write the hypothesis about the x bar bigger than or equal to 60. So all these are wrong. The first one, you forgot to mention what is the parameter to be tested here. The parameter to be tested should be the population mean, so don't forget to write mu. Then the second one, what you need to remember is that the equal sign is usually with the null hypothesis, so it should not be equal 0, equal 60. Then the third one is also something wrong with the parameter. The thing to be tested again is the population mean, not the sample mean. So you should write the mu rather than x bar here. Alright, so this is our first step. Now second step, very easy, is to select the level of significance. Usually this is given in the question. So in this question, our alpha equals to 0.01. Now step 3 is to select the test statistic. So in this question, we will use the t statistic as given in your slides. This is a summary slide for the test statistic to be used. For this one sample hypothesis testing, should we use t or should we use z? If sigma is given in the question, we should use the z statistic. Otherwise, we use the t statistic. In this question, obviously, we don't know the population standard deviation. Therefore, we should use the t statistic. So you can copy the formula behind. Then our fourth step is to formulate the decision rule. So look at the summarized slides. What is the decision rule? There are two ways to report the decision rule. One is to give the rejection region as summarized here. then the other way is to use the p-value. It's always this sentence, reject H null if p-value smaller than alpha. So let's first look at the easy way, the p-value method. So how to formulate the rejection rule is reject null hypothesis if our p-value smaller than alpha. Alpha here is 0.01, so you can write 0.01 directly here. Okay, next is we need to see what is the p-value given this sample data, right? So how should we do it? We go to data analysis. So here we need to find the hypothesis testing. So we can see here under data analysis we have the t-test, 3 t-test, 1 z-test. But all of these tests are about 2 samples. However, for the question here, we only have 1 sample. So how can I do that? One way we can do that is to create a dummy column. We do it later. Okay, we need to create a dummy column. So 0. Then we do it again. Test for pair 2 sample for means. Okay, variable 1 is our cost. Variable 2 is our dummy with all values of 0. Because we start from the label row, we need to tick this one. Hypothesis, the mean difference. Because here we put the dummy at 0, so the mean difference we should put here is 60. Output range, you can choose any empty cell. So I would like to show it here. Alright. Override existing data. So I have some values there. Maybe it's not a good place to report our output. Let me choose another empty cell below this data, okay? Alright. So you can see this is our output from the hypothesis testing. Okay, so you can see our dummy information, mean 0, variance 0, number of observations 15. Alright, so what we should look for here is the p-value. Because in this question, we look at the first hypothesis. We look at the first step. This is our hypothesis. So you should know from the first step that this is a left tail test. Okay, therefore we should look for the one-tail p-value rather than this two-tail p-value. So this is the value we should look at, 0.007. Okay, so in our step 5, let's make a decision and interpret the result. So how to make a decision? Since our p-value equals to 0.007 smaller than alpha 0.01, we reject the null hypothesis. So this is our decision. Now how to interpret the result? Since we reject the null hypothesis, it gives us enough evidence to accept the alternate hypothesis, which is the mean cost smaller than $60. Therefore, the interpretation is like this. We conclude there was an improvement in the cost-cutting measures because we can believe this is because there is enough statistical evidence to support the mean cost smaller than $60. Alright, so this is our step 5. So we complete this question. Now we try to use a second method to answer this question. A method 2. So we use the rejection region. Then look at this summarized slide. If it's two-tailed test, we choose this rejection region. If it's left-tail retest, we choose this rejection region. If it's right-tail test, we choose this rejection region. So for this example, we need to follow the middle one, which is to reject H null if T statistics smaller than minus T critical. So you copy it there, okay? So I just put the word here, critical value, minus T critical. So minus T critical, well, we can find it. We can actually find it from the Excel table as well. As you can see here, the critical value one tail is this value. I use a different color, okay? And we need to compare the T statistic with the critical value. So basically, we need to compare these two highlighted values. So in the last step, when we make the conclusion, we should compare the two T value. So we can write in this way. Since the test statistic is minus 2.802, it is smaller than the critical value, which is minus 1.761. So we reject the null hypothesis and accept H1. And the interpretation is similar to what we have mentioned before. So that's it. Thank you.